Hello, good morning, children.
Good morning, ma'am.
Okay, children. Today we are going to continue with the chapter 3, that is current electricity. So last class we had started with what is current electricity. So we saw that current electricity is the study of charges in motion. Right. Now, if we need to bring the charges into motion, we need to apply the potential difference. We need to apply the. Okay. So, current electricity, it is the study of charges in motion. In electrostatics, we did that the charges were in rest. They were not in motion. Now we are moving the charges. So such a study of charges in motion is your current electricity. Right. Now, if you want the charges to move, right, suppose I drop some water on the table and I want the water will flow over the table. But if I want the water to fall down on the floor, I need to tilt the table. I need to create the height difference. मुझे टेबल को टेढ़ा करना पड़ेगा. So एक end पे the height of the table will be more, and on the other end the height of the table will be lower, and so the water will flow down from high, the point at which the height is more, towards the point at which the height is less, and finally the water will drop down. Similarly, if we want that charges to move, then we need to create the potential difference. And we have studied that a cell produces potential difference, right? And a battery that produces potential difference, right? Now we have studied in the last class the current carriers. So current carriers are those particles which flow, whose flow in a particular direction, whose flow in one direction gives current, right? In conductors, we know that this is your atom, right? This is your atom. And if we go further inside the atom, then what we will see? We will see that inside the atom, we are having nucleus, and inside the nucleus, we are having protons plus neutrons, right? And outside the nucleus, we are having the orbits in which the electrons are present. The negatively charged electrons are moving around in the orbit, right? Now, the electrons which are in the outermost orbit, for example, if we see this, right? So, the force of attraction between this electron and the nucleus, right? This force of attraction will be very, very less, right? The force of attraction will be very, very less between the electrons in the outermost orbit, that is this electron, and the nucleus. So what will happen? This electron, it will gain some energy. If it gains some energy, by taking some energy, it will leave the orbit and it will move freely. It will leave the orbit and it will move freely. So this will be my free electron. This would be my free electron, right? So because of this free electrons, motion in one direction, current is produced in conductors. So who are responsible for production of current in conductor? Conductor में free electrons की responsibility होती है to produce current, right? Similarly, we will be studying semiconductors. There we will see that the charges who are responsible for the production of current, they are electrons as well as holes, right? This we are having an entire unit, there we will study this. Next is, if we talk about in liquids, now in liquids, the charges which are responsible for the production of current are cations and anions. So cations, we know they are your positively charged ions, and anions are your negatively charged ions, right children? Now let's see few more, that is in gases. Now if you talk about in gases, if in normal condition you see beta, in normal condition they are insulators, they do not conduct electricity, no electricity, right? But when you apply high potential difference, आप इसके across if you connect a very high voltage battery, right, or you expose them to x-rays, यहाँ आप x-rays में gas को expose कर दो, then what will happen? This gas will get ionized. Ionized means positive ions and negative ions will develop in the gas, and because of the movement of this positive ions and electrons, current is produced in the gases. So in gases, the current carriers, the current carriers are positive ions and electrons, right beta? Now let's move to the next topic, and that is electric current. Now electric current we have done in class 10th also. Electric current we know that is the rate of flow of electric charge through any cross section of a conductor. So for example, if I am having this conductor, this is my wire, right? Suppose this is my wire. Now this is not this thick, I have zoomed it so that we can see. Now this is my wire, right? Now suppose, now these are the electrons inside the wire, these are the electrons, right beta? Now how many electrons, right? That is how many electrons are flowing through this area, through this cross section in particular time. If I say in this conductor 2 electrons are moving through the cross section in time del t, and in the other conductor, this is my conductor A, suppose this is my conductor B, and in conductor B with the same time we are considering is same, here the number of electrons that are passing are 7 as we can see, and in conductor B the number of electrons flowing through the cross section of the conductor in time del t is 2. So as the number of electrons which are passing in conductor A are more with as compared to B, so the electric current produced in conductor A is more as compared to conductor B, right? Because time is same and cross section is same. So the number of electrons in A is greater than the number of electrons in B. So here in A, large current is produced, I is what? Current, and in B, less current is produced, right beta? Chalo. So we know the definition of electric current, that is I equals to del Q by del T, right? Now if we consider that, see, it is not necessary. Suppose if I am talking about this conductor, right beta? Now suppose I say that 10 ampere is the current flowing through the conductor. Yeah. Now if I take a small portion of this conductor, if I take this area, if I take this cross section is point pe, so is it possible that through this point also the current that is flowing, will it be equal to 10 or will it have some other value? Can you answer? What would be the current? Will it be equal to 10 or it would be some other value? if we take small cross sections of this wire, then the number of electrons which are moving through this small cross section, they are not same, they are different. So the current that is produced 10 ampere is for the entire cross section, this whole thing. But if you take a tiny cross section of this, then the current would be less than 10 ampere. All will sum up, the all cross sections current will sum up, and then you're going to get the total current as 10 ampere, right? So if I want to find out instantaneous current, means at a particular instant of time, suppose this 10 ampere current that is produced in time, that is t, right? बट मुझे t से पहले देखना है at particular instant, उसी instant पे कि अभी बताओ कितना current है, right? So for that instant we will take small time, and that small time is del t, and so the small charge will be del q. So your current small time, so we will take I equals to limit del t tends to 0, del q by del t, and when limit comes, this del will change to differentiation. Differentiation में d आता है, dq by dt. So when you are going to find out the instantaneous current, you will apply limit, and on applying limit, del will change to differentiation d, right? This is for when the rate of flow is not constant. अगर rate of flow constant है, ठीक है, at each and every point, in each and every time, the current that is produced is equal, right? So for that, the formula will change to I equals to q by t, where q is the electric charge and t is the time, right? Now q is what? Q is the total charge. Q is your total charge. Now we know the charge that is flowing is electrons, right? Now the charge of one electron, एक electron का charge हमें पता है. The charge of one electron is 1.6 into 10 to the power minus 19 coulomb. This is the charge of one electron, we know. And suppose the number of electrons which are moving through the cross section of a wire, ये आपकी वायर है, suppose इसमें n electrons move कर रहे हैं, तो इस वायर के अंदर बेटा total charge कितना हो जाएगा? एक इलेक्ट्रॉन का चार्ज होता है 1.6 into 10 to the power minus 19 कूलम. सपोज इसमें 10 इलेक्ट्रॉन्स मैं आपको बोल दूं, इसमें 10 इलेक्ट्रॉन्स है, तो टोटल चार्ज क्या हो जाएगा? 10 into 1.6 into 10 to the power minus 19. सपोज मैं बोलूं इस क्रॉस सेक्शन में 100 इलेक्ट्रॉन्स है, तो चार्ज क्या हो जाएगा? एक इलेक्ट्रॉन का चार्ज इतना है, तो 100 इलेक्ट्रॉन का चार्ज क्या हो जाएगा? into 100. ये कर दोगे आप, राइट? But if I say there are n electrons, then the total charge will be n into 1.6 into 10 to the power minus 19 कूलम. एक इलेक्ट्रॉन पे चार्ज है 1.6 कूलम, और अगर n इलेक्ट्रॉन्स हैं, then the total charge will be n into 1.6 into 10 to the power minus 19 coulomb. That is Ne. That is Ne. So Ne is the total charge in the conductor, right? Where N is the number of electrons and E is the charge on one electron, whose value is 1.6 into 10 to the power minus 19 coulomb. Right? Now this we have done in our lower classes also. In 10th we have done the unit of electric current. Now current unit, we know it is based on the name of the scientist, right? And the unit is your ampere. So it is based on the name of the scientist. So never you are going to write ampere with A capital, right? The symbol for ampere is capital A. Yes, this is a symbol. But when you want to write it full, then you will start with small letter A M P E R E. This I have explained you in class 10th also, right? Do not begin with capital A the full name, because when you write this, this is the name of the scientist. So do not mention with capital A. So the SI unit of electric current is ampere. So this is your ampere. Now we know I equals to Q by T. Current is charge by time. Unit of I is what? Current. Current का unit is ampere. The SI unit of charge का unit होता है coulomb. Time का unit होता है second. Now suppose I want to define 1 ampere. So 1 ampere, 1 coulomb, 1 second. See now how we will define. 1 ampere current कब होगा? When the charge is how much? 1 coulomb. When the charge is how much? 1 coulomb. And the time is how much? 1 second, right? So listen carefully. The current, or we can start with charge. We will start from here, right? If the charge, if 1 coulomb charge is flowing through the cross section of a wire, if 1 coulomb charge is flowing through the cross section of wire, kitna charge? 1 coulomb. If 1 coulomb charge is flowing through the cross section of wire in 1 second, वापस से, if 1 coulomb of charge is flowing through the cross section of wire in 1 second, then 1 ampere current is said to be flowing through the wire. Then 1 ampere current is said to be flowing through the wire. Right, children? So this is your definition for 1 ampere. This is your definition for 1 ampere. There are smaller units also, and they are milli, which is denoted by 1 small m capital A, that is 10 to the power minus 3 ampere. Smaller than that, इससे भी smaller unit है, and that is your microampere, which is denoted by symbol mu. तो इसे ऐसे लिखते हैं, u लिख के you put a line like this. This is your mu, right? So 1 microampere, that is equal to 10 to the power minus 6. So 10 to the power minus 6, 10 to the power minus 3 से भी छोटा हो गया, right बेटा? Now let's talk about the direction of current. This we have done in class 10th also. See, the conventional direction. Actually, we know that in a conductor, the electrons are flowing. We know this, right? That the current is produced due to the flow of electrons. So electrons, they are going to move from negative towards the positive. This would be the direction of electrons, right? So this is the direction of electrons. The conventional direction, that is the direction of the current. The direction of the current is considered opposite to the direction of flow of electrons. Electrons say opposite, you are going to show the direction of current. So the direction opposite to the flow of electrons is the conventional direction of current. So in this, current direction is going to be like this. From opposite to electron, so it is like this. This is your direction of current, right? So from positive to negative. Now, but a current is having magnitude. Yes, current की magnitude होती है, right? Current has direction also. So then, though it is having magnitude, it is having direction, then too it is not a vector quantity. It is a scalar quantity. It is a scalar quantity, right, beta? Why it is a scalar quantity? Because when you are going to carry out the addition of the current, when you are going to carry out the addition, here you are going to apply the simple algebra, right? You are going to apply the simple algebraic addition. You are going to do the simple algebraic addition, right? You are going to do simply the addition. You are not going to apply the law of vector addition, which you have done in class 11. right children? So here you can see that this is our wire A, this is wire B. They are joining together and this is wire C. So the current in wire A is 3 ampere, current in wire B is 4 ampere, and they both are flowing in this. So the total current in C, that is IC, equals to simple addition of IA plus IB, that is 3 plus 4 is 7 ampere. So current is a scalar quantity as its addition is carried out by the simple algebraic addition or the simple laws of algebra instead of applying the law of vector addition. Vector addition laws are not applicable over here. Right, beta? Now, this we will do afterwards. Let's start with this. Okay, children. Now, what happens is, suppose this is our conductor, beta. Now, in the conductor, when no electric field is applied, means you have not connected any battery over here, no battery is connected. So we will call it absence of electric field. No electric field is applied over here. So we know that inside the conductor, there are free electrons. Inside the conductor, there are free electrons, right, beta? Now, these free electrons which are present inside the conductor, they are in continuous random motion. They are continuously moving, right? The number of free electrons in any conductor is nearly 10 to the power 28 per cubic meter. Means in 1 meter cube volume, there are 10 to the power 28 free electrons. कितने सारे free electrons होते हैं, right children? So what happens is, all these electrons, they are moving in a continuous random motion, right? They are continuously moving. And from where do they get energy? They get energy from the surrounding temperature. They get the energy from the surrounding room temperature. And the velocity with which they are moving, they are doing random motion, है ना? Suppose एक ऊपर जा रहा है, ऊपर की तरफ motion कर रहा है, और एक नीचे की तरफ motion कर रहा है, एक left की तरफ move कर रहा है, and one is moving towards right, other is moving towards this angle, next one is moving like this, right? So you can see that the electrons, they are moving randomly, kaise bhi move kar rahe, right? And they are moving with a velocity of 10 to the power 5 meter per second. From where do they get energy? They get energy from the thermal energy, from the surrounding temperature. Surrounding ka jo temperature hai, from there they take energy and they do random motion. And their velocity is about 10 to the power 5 meter per second. Now, their random motion, right? If we take out the average, suppose I say that the electron, what happens is, when no electric field is connected, there no current is produced. Current nahi produce hota. Why? Electrons are moving. Yes, you will say, ma'am, electrons to motion mein. But children, the electrons are not moving in a particular direction. The net will be zero. See how? If you see this electron, this electron is moving in upward direction. Opposite to this electron is moving in downward direction. This electron is moving in downward direction. Now this electron is moving towards left. Similarly, this electron is moving towards right. So up, down, left, right, at this angle opposite to this. So what happens, beta? If we take out the average, then the number of electrons moving in one direction equals to the number of electrons moving in opposite direction to that. So the net movement is zero. They are not moving in a particular direction. So their average velocity will be zero, and hence no current is produced when the conductor is not connected to any external electric field. So this is the case when you see the conductor in absence of electric field. So inside there free electrons are there, and these free electrons, they are going to do random motion. एक ऊपर जा रहा है, एक नीचे जा रहा है, one is going towards left, other is going towards right. But at the end, they are going to cancel each other, and so their average velocity, अगर हम उसकी velocity की average करें, their average velocity will come out to be zero. Right, children? So, children, we will continue with this in the next class. Right? Drift velocity, very, very important topic. What I explained you just now is the mechanism of current flow in conductor, means what happens inside the conductor. So we saw the first case, that is in absence of electric field. So when electric field is not present, the free electrons, yes, they are doing random motion, but they are not moving in a particular direction. So no current is produced, and their velocities, if we take out the average of their velocity, सारे electrons की अगर velocity का हम average करते हैं, then it comes out to be zero. So this is the case inside the conductor when no external electric field is applied. Okay, children, we will continue with this in the next class. Fine.